All right, welcome to another episode of my wild networking series where I focus on network engineering as it might be seen in the wild as opposed to in a book or on an exam. So what I'm doing for that right now is reading RFCs because RFCs are the first-hand account of many internet standards. So that I think is the very definition of network engineering that you see out in the wild. So I was working on getting through the BGP RFC, so I'm going to continue with that. Next section is the multi-exit discriminator. The multi-exit discriminator is an optional non-transitive attribute that is intended to be used on external inter-AS links to discriminate among multiple exit or entry points to the same neighboring AS. The value of the multi-exit discriminator attribute is a 4-octet unsigned number called a metric. All other factors being equal, the exit point with the lower metric should be preferred. If received over eBGP, the multi-exit discriminator attribute may be propagated over to iBGP to other BGP speakers within the same AS. See also 9.1.2.2. The multi-exit discriminator attribute received from a neighboring AS must not be propagated to other neighboring ASs. A BGP speaker must implement a mechanism based on local configuration that allows the multi-exit discriminator attribute to be removed from a route. If a BGP speaker is configured to remove the multi-exit discriminator attribute from a route, then this removal must be done prior to determining the degree of preference of the route and prior to performing route selection. Decision process phases 1 and 2. And implementation may also, based on local configuration, alter the value of the multi-exit discriminator attribute received over eBGP. If a BGP speaker is configured to alter the value of the multi-exit discriminator attribute received over eBGP, then altering the value must be done prior to determining the degree of preference of the route and prior to performing route selection. Decision process phases 1 and 2. See section 9.1.2.2 for necessary restrictions on this. So it's a optional So one thing I would like to do is get a capture of the multi-exit discriminator, but I'm kind of unsure how to do that. I just don't have a clear enough understanding of it. Like, because if it's optional non-transitive, like, it's not going to be passed on to other BGP neighbors, right? But at the same time, if it's intended to be used on an eBGP link, like it's going to be passed over to the eBGP neighbor, right? Yeah, so the multi-exit discriminator attribute received from a neighboring AS must not be propagated to. Okay, so it's non-transitive in the sense that when received from an AS, it will not be sent to other ASs. So a non-transitive attribute does not mean that the attribute does not transit from one AS to another. Basically what it means is that once an attribute is transported or transited from one AS to another, it is no longer eligible to transport to other ASs. That's something I fundamentally misunderstood about BGP. I thought a non-transitive attribute was just ineligible for any transit between ASs, period. So I was actually pretty confused as to how a multi-exit discriminator path attribute could be received across an eBGP link, because I did not think a non-transitive attribute was capable of transit between autonomous systems. But that's not true at all. It is capable of transit between autonomous systems, but once it is transited over between an autonomous system, it cannot be transited over additional autonomous systems. That's different from a transitive attribute. A transitive attribute can transit across any number of autonomous systems. A non-transitive attribute can only transit one time across autonomous systems. Yeah, and not only that, a non-transitive attribute is even more unintuitive to understand and confusing, because internal to an autonomous system, it can propagate through iBGP as much as you would like. So you might get in a situation in the lab where you're on routers 1, 2, 3, 4, and 5, and you see a non-transitive attribute go from router 1 to router 5 and think, oh, well, how is that possible? I thought it wasn't able to transit. It's non-transitive. How is it transiting from router 1 to router 5? Well, they're in the same AS. So transitive and non-transitive refers to autonomous systems. And not only that, the word non does not refer to no transitive capability. It means transitive only one time. So non-transitive does not mean non-transitive. It means transitive, but only once. Transitive means transitive any number of times. Non-transitive means transitive, but only one time. So obviously it's very, very confusing. And that's assuming I know what the word transitive means. Maybe I just misunderstand what this word means. So let's look up the word transitive. Yeah, okay, so in logic, so the mathematical, the colloquial most common way that the word transitive is used means that it's able to take a direct object. So he saw the donkey. Okay, so it's a way of using a verb, and it means that, like, he saw the donkey is like him and the donkey, whereas like for example, he saw. Well, I guess I'm having trouble understanding this. So let's just go down to the mathematical definition, because that's more relevant. And funny enough, that might be a little bit easier to understand. So such that if it applies between successive members of a sequence, it must also apply between any two members taken in order. For instance, if A is larger than B and B is larger than C, A is larger than B. That's a transitive property, since it is true of A and B, and it is true of B and C. Transitively, that same law transits over to A and C. A is bigger than C because we know that it's bigger than B, and we know that B is bigger than C, so therefore we know that A is bigger than C as a transitive property. So you can see the word transitive just is not a good word to use for BGP here. It just doesn't make, like, the colloquial commonly used way of using the word transitive just isn't a good word for here. I'm trying to think of a better word, but I guess shareable is a better word. Shareable. So if they instead called it the multi-exit discriminator is an optional non-shareable attribute, sharing still applies that I took something from you, but now I'm not willing to share it with others. Or I took something from you and I'm going to share it with others. I'm going to allow others to use it. So I wish they had used that term instead of transitive. I wish they had used the word shareable instead of the word transitive, and the word non-shareable instead of the word non-transitive. I think that better explains the concept, but unfortunately, I guess I can use that in this series, and I can use this to myself, and I probably even use it professionally and just call it shareable and non-shareable. But if I do that, I really gotta kind of work through the jargon. Like I probably can do that with somebody who's not that clear about what BGP is. But an expert in BGP, I think I would just confuse them, because they'd have to be like, what do you mean by shareable and non-shareable? When I could have just said transitive and non-transitive, and they'd be familiar with the jargon technical term and know exactly what I meant. So I'm going to keep that in mind. The shareable and non-shareable are better terms than transitive and non-transitive, but I better understand what transitive and non-transitive means now, so I can use that terminology as well. But I think I'll do that if I'm talking to someone who's kind of less familiar with BGP. I'll probably use the words sharative and non-sharative where I would have used transitive and non-transitive, just because it's a much better word. I think the definition of transitive is not what they mean. They're using the wrong word essentially if they're talking about the colloquial, most commonly used words for transitive. Obviously, if they're just using a word to describe what they, if they made up their own word, they're not using the wrong word. But if they did that, they picked a word that already has a commonly held definition and widespread usage. So I would rather that they had used shareable and non-shareable. So the multi-exit discriminator is an optional non-shareable. And again, shareable and non-shareable is still not the best, because it's shareable, but it's only shareable within the autonomous system. Across autonomous systems, you can't share it. It's non-transitive. An optional non-transitive attribute that is intended. Okay, and I read all of this already. So yeah, I read everything down to here. So next section is going to be the local preference section. But before I move on to that, let me read this one more time, actually, because I don't remember what I read, and this is one of my shakier path attributes. The multi-exit discriminator is an optional non-transitive or non-shareable if you're talking about sharing to other autonomous systems, not to other routers within an autonomous system. Attribute that is intended to be used on external inter-AS links to discriminate among multiple exit or entry points to the same neighboring AS. The number, called a metric. The value of the multi-exit discriminator attribute is a 4-octet unsigned number called a metric. All other factors being equal, the exit point with the lower metric should be preferred. If received over eBGP, the multi-exit discriminator disk attribute may be, this DISC stands for discriminator, but I'll just read what it says. Attribute may be propagated over iBGP to other BGP speakers within the same AS. So that's why the term shareable doesn't exactly make sense, because the multi-exit disk attribute may be propagated over iBGP to other BGP speakers within the same AS. The multi-exit disk attribute received from a neighboring AS must not be propagated to other neighboring ASs. So that's what I mean by non-shareable. You can't share it with other ASs, even though you can initially receive it from a neighboring AS. A BGP speaker must implement a mechanism based on local configuration that allows the multi-exit disk attribute to be removed from a route. If a BGP speaker is configured to remove the multi-exit disk attribute from a route, then this removal must be done prior to determining the degree of preference of the route and prior to performing route selection. Decision process phases 1 and 2. So it almost seems like the reason a attribute is non-shareable is because you're required in your networking equipment that you build to write in code to make it non-shareable. Like whether it's shareable or non-shareable doesn't really depend on like the actual BGP protocol. It depends on you implementing the protocol in a way that makes it non-shareable. If a BGP speaker is configured to remove the multi-exit disk attribute from a route, then this removal must be done prior to determining the degree of preference of the route and prior to performing route selection. Decision process phases 1 and 2. An implementation may also, based on local configuration, alter the value of the multi-exit disk attribute received over eBGP. If a BGP speaker is configured to alter the value of the multi-exit disk attribute received over eBGP, then altering the value must be done prior to determining the degree of preference of the route and prior to performing route selection. Decision process phases 1 and 2. See section 9.1.1 for necessary restrictions on this. Okay, so that's it for the AS path attribute. I understand it a lot better now. I understand the difference between transitive and non-transitive. Before I thought I understood it, but I had a misunderstanding. I thought that non-transitive meant that it couldn't transit between ASs, but that's not true at all. It can transit between ASs, but it can only do it once. A better way to say transitive and non-transitive, using language that's more easy to understand, would be shareable and non-shareable. Because if something is non-shareable, you can still receive it from someone else, you just can't share it after you receive it. So that's basically what they mean, is shareable and non-shareable. Between ASs, within an AS, a non-shareable attribute is shareable to other IBGP neighbors within your AS. But across ASs, a non-shareable attribute, even though it was received from another neighboring AS, cannot be shared. So I think that makes a lot more sense than the terms transitive and non-transitive. So before moving on, I would like to see this. So the only way we can see this attribute is across a eBGP link, which we have here and which we're tapping with this box here. So we can because this is a hub, it'll broadcast the traffic out all the ports. So we can sniff this link to see the packets. And then we can modify them, mess with them using SCAPI on this box here, but that's more advanced. I have to learn how to do that. But we can look at the configuration on here, and we can send updates and all that sort of thing, and see if we can get the multi-exit discriminator to show up on those updates as an additional path attribute. I believe right now we've only got 3 patch attributes. So let me get an update message. So to get an update message, I've got to make a change to BGP or to the routes that are entered in to BGP, and I can do that by deleting the loopback interface. There we go. And now I'll get an update message with a withdrawn attribute. Yep. And we can see, and I prefer the bits. Okay, so we can see the 4.4.4.4 was withdrawn. So let's roll that back and add that back in. And now we're going to receive that back, this time as network layer reachability information. There it is. Here's our 4.4.4.4. And now we've got our path attributes. And we're only going to receive 3 path attributes. These are the path attributes that are required with every update message. Oops, it looks like my camera stopped. I'm going to restart that. I should get a better setup. I'm sorry for the qualities of these videos. It's so bad, but most of what this channel is to motivate myself to study. I'm a little bit more motivated to study and to study carefully if I'm on camera. Because if I'm not on camera, sometimes I have like longer breaks, and so this is more for me than for you. I apologize for that. As I do these longer, I might do a series that's more professional, but right now this is just a hobby of mine. Okay, so let's look at the path attributes. So right now we've only got the 3 not well-known attributes. They're not optional, so we can see they are well-known, which is different from optional. I wish they would say, like, the terminology behind BGP is so bad. It's just broken. Like, I wish this would say shareable, and then I wish this would say required. So I wish instead of optional and well-known, they had optional and required. And I wish instead of transitive and non-transitive, they had shareable and non-shareable. So, but you can see here we've only got 3 path attributes. These are the well-known attributes, which if they were using better language for BGP, they would call them the required attributes. There's only 3 required attributes. We've got all 3. Any optional attribute, don't have. All right, so let's try to get an optional attribute. Oops. Okay, so we're going to set the MED. Oh, how do we set the MED? I think we can set the MED. I think the only way to set the MED is to set it for the specific neighbor, and that's because it is to determine which neighbor to send the traffic to. So you have to send it to each neighbor, and the traffic is going to be preferred on that link. So on my AS, let me get my hand drawing out, and it gave me issues last time I tried to use it. The drawing software I tried to use is giving me issues. Usually they let you have a 1-hour demo, but they're not letting me have that now. Yeah, they're like requiring me to log in from my tablet now, and they're not requiring that just from. Oh, and I can't just hold down. I have to just continually click the backspace button, because if I hold it down, it deletes everything. Yeah, so like I can't. Like they're forcing me to log in now, and like it's just not working the way it used to work. Yeah. Like it automatically, like if I log out and then I refresh, what if I go to like incognito mode? Because I just want to use the 1-hour demo that they offer. Okay, perfect. If I go to incognito mode, I'm able to use the 1-hour demo that is offered on their site. Okay, so here we go, perfect. Okay, and then it's going to be dash S and it's PTCBW 2.1. Okay, there we go. So now what I wanted to draw is, yeah, an autonomous system. So let's have autonomous system 1 and 2. So here's autonomous system 1. And then here's autonomous system 2. I can, yeah, there we go. So now within this autonomous system, you're going to have any number of routers. And then you'll have, of course, any number of connections between the autonomous system. So here's a connection between it, here's a connection, here's another connection. And then these all have whatever connections they have. You don't need a full mesh as long as you're using route confederations or route reflectors. So what this multi-exit discriminator path attribute is for is you can say to autonomous system 2, even if you don't have the access to it, because this belongs to you and this belongs to me. So you're not going to let me go on your gear. It's yours. It's your private gear. I don't get your passwords. I don't get access to your VPN. That would be just, you know, a nightmare to just let random people into your network to do routine basic things like this. So what I can do is say, hey, so we're BGP neighbors, right? You and me are BGP neighbors. So here's an additional path attribute that I would like you to include on your routers. It's called the MED. And on this link, I would like, for this neighborship, I would like that MED to be 1. On this neighborship, 2. And this neighborship, 3. The reason I want you to have those attributes on your AS, which I can't configure myself, I can't log into your gear and configure it, is because I want you to favor this link here. I want this to be the link that you use. And then if there's an issue with it, I want you to use that other link. But I can't log into your router and I can't tell your routers which link to use. But what I can do is send you a multi-exit discriminator value, and your routers automatically know, based on that value, which which link to use. So it's a way, from what my current understanding of it, and hopefully my understanding of it is correct, is that the multi-exit discriminator value is basically a way you can configure the routers in another autonomous system without having access to them. And that's important because you want to be able to favor links without having to call up, you know, the person responsible for this autonomous system, gain access to the devices. You know, that's a whole thing it's insecure, is time consuming. So you just send them an extra attribute and their routers automatically know, just as the basic foundation of the BGP protocol, to favor this link right here instead of the ones with the higher MED value. I believe it could be the higher ones are favored, but I'm pretty sure it's it should say right here, it should say, yeah, so the lower metric is preferred. I was correct. Okay. So that's my understanding of that. Let's try to configure that. So if my understanding of that is correct, it's going to be under the neighbor. So let's go to edit mode. Okay, and we'll do set. Okay, so maybe my understanding of that is not right. Yeah, it might not be correct because I don't see where the MED is. Maybe the preference is probably the local preference is what they're talking about. We can do a help. Oh, that's interesting. Oh, okay. So they call the metric the MED path attribute. They call that the metric out. So they kind of use jargon to talk about jargon. Um, and it looks like it applies to routes labeled with a particular community. So you can do it. If I go back to my drawing here, you don't have to do it based on what the link is, and you don't have to say, hey, you know, here this link has an MED value of 1. Prefer that link. You can say for all routes that are labeled with the community attribute, link 1 routes, and these routes are going to be let's say because it's a public, because BGP will be handling, eBGP will be handling public routes, unless it's in the lab. But in the wild, which is what this series is all about, we'll have a public address. So let's do 172.17. Oh, sorry, that's 17. That's a public route. Oh, sorry, no, it's not. Dot 172 dot. Let me think here. 32/12. That's a public route. So for that route, it will be yeah. So for this route, we can give it the community attribute of link 1 routes, and then it knows to go over a link 1. So you can choose which link it exits the neighboring autonomous system over using that. And it's a non-shareable attribute, so you can't pass that to other autonomous systems. The other, for example, if I was connected to autonomous system 3 over here, they would need to set their MED values there. Okay, and I think I've got this. It could be. As I've said, I don't have the best understanding of the multi-exit discriminator value for BGP. That's what I'm hoping to gain right now. So let's try enabling that metric out thing and see if we get that new path attribute showing up. Okay, so according to the help doc here, configuring the MED metric, we're going to set the MED metric to 20. In the example, we would do it for all BGP update messages except for those sent to a particular peer. So for this peer here, we're going to set it to 10. So it looks like you do set it. So you can set it to the group so that all neighbors within the group get the same value, or you can set it on a neighbor by neighbor basis. It makes more sense to do it neighbor by neighbor because that's kind of the point of it. There's really no point to just sending it for one link. The purpose of the multi-exit discriminator value is to single out links over the other. But if you have a group of neighbors separated by another group of neighbors, say you have 10 neighbors in a group, 20 neighbors in the other, instead of having to go to each neighbor 20 times, you can just apply it to the group, assuming that's the way your network is designed. So there's lots of, yeah, so let's see here. So we're going to do edit, protocols BGP, group test, show pipe displays set relative. Okay, so now under these particular neighbor, let's do it for this is router 4. So we've got we've got a neighborship down here. We've got a neighborship up there. Yep, and they're labeled clearly. The 600 I think will be the one up there. So let's do that one because that's the one we're tapping. We're not tapping this one, so we won't see the MED there because it's not going to be sent through the tap. So if I do neighbor like that, now I can do set metric out. And let's take a look at what this says. Yeah, route metric sent in MED. So they're using jargon to describe jargon. I wish they would just use like MED or multi-exits DAS as it says in the RFC, but unfortunately we've got to learn the Juniper jargon to be able to configure the BGP jargon. Okay, so let's set the value to 400. Okay. Perfect. Okay, so the value is set to 400. We should get a update packet, I think. Oh, we got a notification. Why did we get the? Oh, so setting that value, it looks like it reset the neighborship. Yep, so the neighborship got dropped and reset after I set that value. But we got our open messages back. Yeah, so now we've got our routes coming back, and sure enough, we've got the multi-exit discriminator, non-shareable, which means non-transitive, optional path attribute included in there. Now that we are receiving from, if I look at the packet, .1. So let's see, is this .1? I don't even remember. Yeah, this is .1. So this is a packet that is going this way. It's R4 sending it to R6. So R4 sends that multi-exit discriminator value over to R6. Let's see what R6 did, because R6 sent a update message as well. Does it include that value in its updates? I am guessing that it is not. I'd be willing to bet a very small amount of money that it is not. Okay, and I was correct because it's only configured on R4. But the thing is, and the thing that's kind of unintuitive, I think, is that I guess I want to say that it applies to routes being sent from R6, but I actually don't believe that. I think it applies to routes being sent by R4. So if we had, let's try this. So let's try forming another neighborship, and we'll put it through the tap. So let's form another connection. We'll do it on the last available one. Okay, so now we've got two exits that we can discriminate. So we have multiple exits, and we can use a discriminator to prefer one exit over the other. So let's do that. So show configure. Okay. So I've got /30 routes. Let's go ahead and set up that other one. So show in terse pipe match up. Yeah. So 9 is up. So configure private edit face 009 dot 0 set family INET address. Now let's use like 99. Yeah, .1/30. Just it's a little bit clearer that way. Okay, and now let's go over and set up the other side. We'll need more configuration than just that. We'll need BGP configuration as well. Okay, well, I know what I need to do. Edit int g009.0. That's 0. Set interface or set family INET address 9.99.99.99/30. Ping. Okay, perfect. So we've got that part done. There's another part. We've got to form the actual neighborship. So it's going to be under protocols, BGP, and it will be. Now we can make a new group for it, but let's add it into this group. So metric out is going to be the way to do it. Okay, and we'll call this metric 99. And it's the lower one that wins. So this will be the loser for now. Oops. Oh, right, the AS number is required. So set protocol. BGP group test neighbor .99.99.1 peer AS because it's type external, so it's requiring that 400. Okay, perfect. And then it'll be 600 on the other side. Okay, and then it'll be metric. Oh, let's just set the metric out on one side instead of both sides. So we're gonna do delete metric out. Perfect. Okay. And then on this side, we're going to set metric out value of 99. And there we go. Okay, so let's take a look at the configuration now. Okay. Okay, so here we've got neighbors. We've got the no difference between the neighbor configuration here. Here we do have a difference. We have an additional neighbor. I think I'm just going to remove that for now, just to make things a little bit more clear. Okay, so this will make the configuration a little bit easier to read. Oops, and I'm getting a headache. Okay, so now we've got PRS, and we've got differing metric out values. Let's change the metric out value here to 10. There we go. Okay, we'll look at the configuration again. Oh, yeah, here we go. Okay, so this is really nice and clear, I think. So what we should see now the next thing we're going to do So we're going to keep the Wireshark capture going. Now we'll see, and I'll bring up the sketchpad, and I think I'm gonna, yeah. So here's the two things we might see. Now, if I'm correct in my interpretation of this, when I go ahead and shut down or toggle the interface, and I made a new, so let me put a line down there. Okay, perfect. So put that line on the top of the page. Okay, we're good there. So we've got two routers like this is our topology essentially. So, and then we've got a loopback here. So LO0, and then we've got LO0 here. So when we shut and no shut, well, when we no shut L0, when we shut, we'll get a withdrawn route. But when we no shut, we'll get an update, which is what we're studying here. When we no shut this, we'll get an update going this way, and that update will not have a path attribute. That update will not have the multi-exit discriminator path attribute. So let's take a look at that. So we're going to start on R6. We're gonna do a set interface LO0.0 disable commit, and then a rollback 1 commit. So we got our update message, and we got it across both links because we don't have any. So that's interesting. That's data. So we've got when I brought that up, we had our traffic go down both links, and we didn't have a multi-exit discriminator value. Oops, that's my withdrawn. So here's my, here's my withdrawn. Okay, so let's bring it back up and see what kind of update messages we get. So we got two update messages. We've got one, so we've got one across that link on the top there, the 10 dot link here, and we got one across the link on the bottom there. So it came out of both links. We've got two update messages, but we don't need both of those. We only need one of those. So and we don't have the multi-exit disk path attribute included because that's not in the configuration. So I think that is proof enough that my conception of how this works is actually incorrect. How it actually works, see how I thought it worked, and we can see that by going up here, is that you sent a multi-exit discriminator value to another autonomous system, and then in that autonomous system, they send their routes based on that value. But that's not how it works. It's only local to your autonomous system. I gave the whole speech about being able to modify somebody else's autonomous system, and that kind of rings true because when you modify your own autonomous system, it affects the links they receive things on. So it's kind of not entirely false, but I would say it's mostly false. When you set a multi-exit discriminator value, it only affects your autonomous system. You only change something on your autonomous system. You send something that is read by the autonomous system. So it's not like you basically give someone a book and then they read through your book when you ask them to do something to see if to interpret what you're asking them to do. It's you ask them to do something and you say, oh, but please also. So you're including extra information in how you want them to handle your request. So let's take a look at that on the other side. And I'm sorry, I've got to stop this video in a few minutes. Okay, so I shut down this side. You can see we've got two update messages. But I would be willing to bet for a very, very small amount of money that when I do a rollback, we're only going to get one update message because we have a multi-exit discriminator value. So we're only going to get it sourcing from 10.10.10.1. Okay, so you can see I was wrong about that. We got it from across both links. Okay. So clearly I still have some gap in my knowledge there. Unfortunately, I got to end the video here, but when I come back for my next video on BGP, I'll be learning more about what this means. I think it means when you actually send, I think I was right actually, this is something I'm still not sure of, that it does affect what's happening in the other autonomous system. I think it means when you send a route to one of these here, so when you send a route to 4.4.4.4, I think it means that you will, I don't know what it means. Well, anyways, let me just not come up with an explanation that's going to be wrong and have to work through my misunderstanding. Let's try to keep my mind blank and open about this and learn about what it means just based on what I'm hearing and not based on some false interpretation or assessment I make. All right, but that's the end of this video. Stay tuned for the next video where I figure out what the multi-discriminator exit is, because obviously I do not understand its path attribute, and hopefully if there's enough time in the next video I'll move on to the local preference, which I do understand a bit better. But thanks for watching, and I'll see you in the next one.